In the name of Almighty Allah, the most gracious, the most merciful. As Muhammad, peace be upon him, narrated, if anyone travels on a road in search of knowledge, Almighty Allah will cause him to travel on one of the roads of paradise. Hello everyone, this is Dr. Tariq Masood. Thank you very much for watching my videos and your wonderful support to make the channel a grand success. We are a family, a partner. Please share and subscribe our channel if you haven't done so far. We as a team can work together to convert challenges into opportunities and opportunities into success stories. These success stories can be monetized into value addition in the world by large. Thank you very much for your precious time. Today I'm going to discuss my lecture number 3 on fluid catalytic cracking emergency shutdown procedure. Okay, before my lecture I used to read a Quranic verse. قال ربي اشرح لي صدري ويسر لي أمري واحلل عقدة من لساني يفقهوا قولي اللهم ربي زدني علما. O my Lord, open my chest and ease my task for me, and loose a knot from my tongue, that they may understand my saying. Allahumma rabbi zidni ilma, O Allah, advance me in my knowledge and true understanding. Okay, fluid catalytic cracking, FCC unit, emergency shutdown procedure, lecture number 3. Okay, key takeaway points from lecture number 3 on emergency shutdown procedure. In my earlier lecture, we have already discussed behind in burning or after burning, boiler feed water failure, cooling water failure, electrical power failure, instrument air failure, main air blower failures. Today we are going to discuss main column bottom pumps failures, oil reversal, plugged risers, loss of feed, slide valve failure, hydraulic oil supply failure, controller malfunction. We are going to discuss 2 more. Okay, next slide, key takeaway points. Dispense cutter slide valves, regenerated cutter slide valves, recirculation cutter slide valves, flue gas slide valves, wet gas compressor failure, cutter cooler, loss of boiler free water to cooler, cutter cooler, lift gas failure, blackout systems, high temperatures at spare a tower, or FCC unit upsets, cutter cooler, fluffing air compressor failure. Okay, emergency shutdown procedure. The most important aspects of an emergency situation is to put the FCC unit into a safe position. This may involve stopping the raw oil feed to the reactor for a period of time to correct the problem. If this is necessary, the basic steps to keep in mind at times are: number 1, increase riser lift steam, feed steam, and steeping steam. Number 2, bypass raw oil feed to the main column and stop lift gas. Number 3, establish a negative reactor regenerator pressure differential. Number 4, lower the reactor pressure. These steps remove the hydrocarbon from the reactor, established a steam barriers between the regenerator and frictionation section, and maintain a good vapor velocity to assist a catalyst circulation. When these conditions are established, the problem area can be investigated and corrected. However, it is emphasized that every emergency situation must be handled individually depending upon the conditions existing when emergency originated. The following recommended procedures provide a sequence of major steps which must be taken for the most likely emergency situation. Remember, bypassing raw oil feed and stopping lift gas is done by bringing hand control valve into position shutdown condition. Okay, main column bottom pump failures. The main column bottom circulation circuits remove about 25% of the heat from the reactor vapors. If the flow is lost for more than 10 minutes, the unit must be shut down since the bottom residence time and temperature would increase to the point where coke formation would begin. Also, the loss of bottom circulation could result in heat damage to the disc and donut trace and catalyst carryover up the column. Number one, first priority when a bottom pump fails are to get the materials out of the column and keep the bottom temperature down. Try to start the spare pump immediately. Reduce the charge rate up to 157 meter cube hour and lower the reactor temperature by 30 degrees Celsius. Decrease product draws slightly to add in quenching the column bottoms. Number two, if it is not possible to start the spare pump immediately, continue decreasing the charge rate. Increase steam to riser when the charge rate is below 60% of design to maintain catalytic circulation. Number three, it is not possible to start at the pump within 10 minutes. Increase riser steam, increase feed steam, bypass the raw oil charge to main column, and stop the raw oil feed. Fully close the regenerated and spent catalyst slide valves. Established a negative reactor pressure differential and lower the reactor pressure. Okay, continue internal catalyst circulation in the regenerator. Inject a torch oil to hold the regenerated catalyst at 650 degrees Celsius. Number 5, after raw oil is bypassed from the reactor, the wet gas compressor spillback pressure control valves will open. Add a fuel gas to the light cycle oil stripper overhead line as needed to hold the main column pressure and maintain the reactor pressure above that of the regenerator. Number 6, when a bottom pump is operational again, pump the column bottoms down to working level. Start the column pump around circulation and follow the normal procedure for putting the unit back on steam. Okay, next, oil reversal. Oil reversal. The raw oil charge is contacted by regenerated catalyst at the base of the riser. The oil vaporizes and increase in pressure forces the mixtures up the risers. If a conditions arose where there was sudden increase in reactor or main column pressure or decrease in the regenerator pressure, the oil could be forced to backflow through the regenerated catalyst standpipe into the regenerator. This is known as reversal. Once the regenerator, oil will burn, resulting in extremely high temperature. A severe reversal may cause a temperature to exceed 1100 degrees Celsius, well over the design temperature of regenerator internals. If a reversal occurs, following action should be taken immediately. Number 1, bypass the raw oil charge, increase steam to the riser, increase feed steam, and close the regenerated and spent catalyst slide valves. Lower the reactor pressure and maintain negative reactor regenerator pressures differential. Stop lift gas and block in the control valves. Number 2, check the regenerator temperature. If they pass 760 degrees Celsius, decrease the air rate. It will also be necessary to decrease the recirculation catalyst flow in order to keep the catalyst fluidized at the reduced air rate. Increase air to the catalyst cooler and open the slide valves to help remove excess heat. If the regenerator temperature continues rising, start a small circulation of catalyst to the reactor. This will remove some of the heat from the regenerator. However, do not allow the reactor temperature to exceed 540 degrees Celsius. If it is not possible, circulate a catalyst using riser steam. Decrease the air rate as much as possible and wait for the oil to burn off and temperatures to drop. Okay, plugged riser. This condition can be resulted from having insufficient steam in the risers while circulating catalyst or too much catalyst relative to the oil vapors to lift it up the riser. In either case, the catalyst will slump and may plug the riser. The slumping condition can be recognized by number 1, the loss of differential pressure. across the regenerated catalyst slide valves. Number 2, a sudden drop in the reactor temperatures. Number 3, sudden drop in a main column temperature. Okay, the following condition should be taken immediately. Number 1, increase lift steam and feed steam to the risers. If this does not clear the risers right away, shut off the riser steam and bypass the raw oil charge to the main column. Close the regenerated and spent catalyst slide valves. Maintain internal catalyst circulation in the regenerator and hold the catalyst temperature at 650 degrees Celsius. Okay. Close the regenerated and spent catalyst slide valves. Maintain internal catalyst circulation in the regenerator and hold the catalyst temperature at 650 degrees Celsius with torch oil. Okay. Okay. Open a dry steam to the blast connections on the bottom of the risers, Y connections. If the plug cannot be cleared, then the Y sections must be drained and are vacuumed through a 4-inch vacuum connector and the blast cooler. Be careful as this catalyst is hot. Okay, number 5. When the riser is clear, so the close a main column steam, start the riser lift steam, start the feed steam, and begin catalyst circulation. Bring the unit back on steam following the normal startup procedure. Okay. Okay, loss of heat. If a loss of charge occurs, the unit must be shut down immediately. Immediately increase lift steam and feed steam to the riser. Close the regenerated catalyst slide valve. After a few minutes, a riser should be free of catalyst and the spent catalyst slide valve should be fully closed. Establish a reactor pressure higher than the regenerator by adding a fuel gas to the light cycle oil. Steeper vapors return the line as needed. Block lift gas control valve. Okay. Shut down the wet gas compressor and lower the reactor pressure. Start torch oil to the regenerator, holding the catalyst temperature at 650 degrees Celsius. Continue internal catalyst circulation in the regenerator or through the recirculation catalyst slide valve. When raw oil is available, bring the unit back on stream following the normal startup procedure. Okay. Slide valve failure. So hydraulic oil supply failure, controllers malfunctions, physical damage to the valve. Okay, hydraulic oil supply failure. A loss of hydraulic oil pressures could occur due to loss of hydraulic oil pump or ruptured hydraulic oil line. The loss of hydraulic oil pressure will result in the loss of control of the slide valve and will leave the valve in the position it occupied when the failure occurred. Should hydraulic oil supply failure occur, the slide valve must be put on a manual operation. If the unit operation is steady, a major upset and need not result. However, the unit will drift off control and immediately action must be taken. Number 1, for those cases when the hydraulic line remain intact, the slide valve main hydraulic oil accumulator will provide hydraulic fluid to the actuator to move the valves to full stops. However, if the valve is not moved within approximately 4 minutes, the accumulator will have depressurized and will be unable to move the valves. Okay, when the individual main accumulator pressure is depleted, switched for spent catalyst slide valves, for the regenerator slide valves, for the recirculation catalyst slide valves, for cooled catalyst slide valves, for the cooled catalyst slide valve number 2, for the flue gas slide valve to the reserve accumulator, which will again provide 2 full stroke of the valves or about 4 minutes of the operation time. When the reserve accumulator is switched on, it will activate the control aboard alarm, reverse accumulator in service. Okay, when the operating the regenerated catalyst slide valve by hand wheel, closely watch the catalyst slide valve differential pressure so a flow reversal does not occur. Okay, number 2, if the hydraulic oil pressure can be re-established, quickly put the valves back into regular operation. For a prolonged failure, the unit must be shut down. Malfunctions. A slide valve will close upon the loss of its actuator electronic power or instrument signal. Since there is no allow for those failures, they will only be apparent to the board operator when he sees that the slide valve is drifting to the closed position. In this case, the slide valve must be operated using the hand pump, the hydraulic oil supply, local manual positioners, or the hand wheels. If the electronic input to the actuator circuit aboard can be re-established quickly, put the valve back into regular operations. For prolonged failure, the unit must be shut down when it is necessary to operate the regenerated catalyst slide valve locally. Care must be taken to maintain a positive valve differential pressure so an oil reversal does not occur. If this does occur, refer to the other reversals for the emergency step to be taken. Okay, next, physical damage to the valve. The loss of slide valve control should be the result of access disc erosions or broken shaft. Corrective actions to be taken depending upon the valve affected. Today we have discussed main column bottom pumps failure, oil reversal, plugged risers, loss of feed, slide valve failure, hydraulic oil supply failure. Okay, today we have discussed main column bottoms pump failure, oil reversal, plugged risers, loss of feed, slide valve failure, hydraulic oil supply failure. Okay, so these are a few references here. Okay. Please do not hesitate to send me your feedback, comments, t.masood.dr@bath.edu. Thank you very much and stay blessed.